Hey, Larry Mednick here. So today we're going to be upgrading a 6-blade Excalibur E-props to the latest and greatest 5-blade with the titanium leading edges. And then on the REVOLT we use our own in-house CNC hub with spool spacer that's integrated. And so basically one of the reasons the customer wanted to upgrade his prop is the new prop does perhaps have a little bit more thrust, but not a big performance change. This thing is pretty impressive. However, it does have just the raw carbon fiber leading edges. So what you're looking at here, and you can see they're in pretty good shape. He's got about 300 hours on this, but these leading edges do need to be refinished from time to time. And then the other part of that equation is that this hub requires a 25-hour retorque. So if you fly a lot, it's just one of those things where you're always going back to the retorque on it. And part of the reason it takes a retorque as often as it does is it's a hollow carbon fiber prop. So E-props has gotten away from that because they realize that not everybody is doing the 25-hour torques, and they've gone to a solid carbon fiber hub that does not require that kind of maintenance regimen to make sure that those blades remain tight. So this one here just takes a little bit of extra maintenance both on the blades and the torque, and then wait till you see this new prop. So what we've got over here are all the tools and parts that we're going to need. So obviously we've got a much different style CNC hub, and this is specifically designed for the REVOLT. If you notice, you can see it better on this side. These 6 are for the drive lugs, and these are for using a set screw with a dynamic balance. So we've got a place to actually add weights to this particular hub. If you're purchasing just a regular E-props propeller straight from the factory, find lead weights stuck inside of their hub system because they do a beautiful, beautiful job of dynamically balancing the prop. So we've got kind of a little extra step, but to be honest, as smooth and balanced as the prop blades are, we generally don't need a dynamic balance. In other words, if we put the Dynavibe on it and run it, we're going to find out that it is within spec and then some. So very, very rare that we'd need to add any weights, but we have that ability to do so. So a couple tools. We've got our 6mm Allen wrench, 13mm socket, 7/16 wrenches. We've got our mallet for setting the blades, our torque wrench. We've got our protractor, our digital protractor, and then this is a really interesting tool. You'd only need this tool if you already have an E-props with the pressed-in drive lugs already. So I'll show you how that works in just a bit. We've got our 5 prop blades here and our neoprene prop cover. So we're going to get started here. Take our 6mm, and we're going to just go ahead and unscrew our spinner cone. And so I'm going to now you hear that crackling there. That is the sound of a Nordlock washer. That's the locking mechanism that stops these from turning back out. So there's no safety wire, there's no nylox on this side, but this washer is an anti-rotation device that keeps these bolts tight, and it works very, very well. And so the reason that this particular hub needs a retorque is not because the bolts are backing out, it's because of the volatility of the hub. And so the hub can actually shrink a little bit, and that's the reason that these bolts would need to be retorqued. So get all these guys going here. And this guy here. And this one here. As you're torquing, you want to do a star pattern. As I was just kind of loosening it, it's far less critical. But I've gone ahead and gotten my little impact driver with another 6mm Allen, and I'll go ahead and remove these, except for the top one. So in other words, right now I want to make sure something's holding this very expensive propeller on the aircraft, and so I'm going to kind of hold this prop. Now the prop's being held together in the center, and what that means is when I take this off, the whole propeller is not going to fall apart, which is really nice. So here we go, and just gotta stay with it. Probably it's not going anywhere because you do have to kind of work it off. Now what a lot of people make a mistake is they'll actually take the the last bolt out, and they'll start pulling blades, and hopefully they got 5 friends to help them and not fall on the floor. Then they can't get the hub off because the hub really needs to be wiggled off. So these prop blades make an excellent lever. You don't want to come way out. You don't want to put any stress on the blades, but in here is fine. And that's going to allow me to remove this prop. And then the prop as a whole, we can set off to the side.
Do you want to show the hollow prop part?
Yeah, so taking a quick peek at this. And again, when we talk about hollow, we don't mean it's hollow here. Inside of here is actually hollow. It's a foam filled, just like these blades are hollow blades. They are solid carbon in the leading edge section, and then they go to hollow. And so that same technology of the blades has been put into this hub. Extremely light. I think this propeller weighs something around 5 pounds. It's very, very light. And our new hub is much, much heavier. Our hub is about the weight of this entire propeller. But the magic behind the E-props is the low moment of inertia, so you get the very smooth startups, you get the very smooth shutdowns. And just because we're using a heavier hub, we're still going to use the super lightweight blades. I don't think anybody builds a blade this light. And we still get the same effect because that moment of inertia is very, very light. So now, and unless you have a huge, huge table with a 70-inch diameter, you're going to need the floor, the ground. So I wouldn't recommend putting it down on any kind of a rough surface. Grass will work, a painted, smooth floor will work. And so we've got 5 blades. Again, if you're putting together the E-props entire prop assembly that came from the factory with the E-props hub, the E-props hub is going to be color coded, and you'll find those colors on each blade. Now our hub does not have corresponding colors to it, and I'll show you how we figure out where the blades go. The blades are serialized, and they start with the lightest blade and they move towards the heaviest blade, which means if you just put the serial numbers in order as you go around the prop hub, you're going to wind up with the heavy blade next to the light blade, and that's going to give you the best balance. Again, they're all extremely close. They're not just statically balanced. It's a lot more than that. And so typically you might be able to get the blades a hair better if you do a dynamic balance after the fact. And again, that's with our prop hubs. With the E-props, it's already there. They've already added that little tiny piece of lead weight somewhere on your prop hub, and that makes it perfect. So what we're going to do is we're going to figure out what our serial numbers. I got a 27, 30, I got a 26. All right, so we're going to start with the 26. That's our low number. We're going to walk over. We're going to start here and go 26, 27. Looking for my 28 and my 29. And my 30. We're going to take our fully threaded 8mm bolt. We're going to install a Nord lock washer. And so what this looks like is this on both sides. But the real magic, if you split this apart, is the way they fit. So these are like little ramps that go around, so they can click one way but not so much the other way. You saw what a difficult time I had getting those to break loose the first time. So that's the Nord lock, and this is the only Nord lock on our prop. So we're going to go ahead, put that through. Again, this is CNC. In our case, there's no dots to line up. We're going to just find where the blades go. We're going to push this down and squeeze this hub with one center bolt. And now we are back to where we're at with the old prop, which is that it's a complete unit and it's ready to get hung. Now here's the problem that we've got. These drive lugs, and again this is an E-prop specific drive lug, these are pressed into this drive flange. You could whack those with a sledgehammer and they're not coming out. They have to be pressed out. So if you need to remove this type of drive lug, I've only found one way to do it, and that is to use this little tool. This is sold by eProps, and if you show this to pretty much anybody, no one can figure out how this works. So let me show you. The first thing you want to do before you start, and you can even see I've used this tool quite a bit, is you want to take some ACF 50 or some kind of lubricant, and you want to oil the tool because it's going to take a lot of friction. You're going to see in just a moment how this little tool works. Remove. So we'll just go ahead and start at the top. Put that all the way in. Then we're just going to remove these outside nuts here and here. And then it's going to go through these holes, which are not used for anything in our application. And then we're going to get the nuts on the backside. And if it's not coming through enough, you may have to adjust these nuts so you've got plenty of threads coming through. And what I'm really looking for is that this tool is square to the flange. So basically that's kind of, I can move that out a little bit and then go ahead. And getting back here is a little bit difficult. You just have to kind of use your fingers, and you don't need to put a wrench on this. This is just a finger tight application, and you want to be able to manipulate this because you want to be able to line up the Allen wrench now with this bolt. And now we're going to actually loosen this, so we're going counterclockwise, and I'm starting to feel, and I'm pulling pretty hard, but it is pressing out, in fact. And sure enough, it's coming. And once you get it fairly loose, you might be able to switch back over to the impact. This particular one just doesn't have as much power. And there it is. So now that guy is loose, and we're going to multiply that by 6. We got to go all the way around, and we got to remove each one of these drive lugs.
Is there a reason why you can't reuse the same drive lug pattern?
Yep.
Same
So these drive lugs, two things. They're threaded, and so the first thing is the bolts that go into these need to enter from this direction. And when you see the new hub, the bolts are going to enter backwards. The second thing is they need to have a Nordlock washer on them in order to use a threaded drive lug. So we're going to use AN bolts with nylock on both sides. And what that's going to do for us is give us our locking mechanism and get into a space that you normally can't get to from the front of the hub. If you notice, the base of these blades is much, much smaller than the new blades. And then obviously the hub is actually much, much smaller as well. So this is a much beefier, bigger propeller. It's not bigger in diameter, but the blades are bigger, the hub's bigger, everything is beefed up on this new prop. And the sound is just awesome, and the performance is fantastic. These are the titanium leading edge protection, and that is actual metal that is built into the mold. It's all laid up together. And there's no lip here either. A lot of times you get these metal leading edges, and then what happens is you have paint will peel up right along this edge. Well, there's no paint to peel up, and it is perfectly flat. So you're not gonna get any wear where the metal ends and the carbon fiber stops. Okay, on the original propeller hub, that's all metric hardware. These are 8mm threaded metric hardware drive lugs. I want to touch on that for a minute. A lot of props in this category of aircraft will simply rely on the bolts to turn the propeller. So what a drive lug does is a drive lug is what's responsible for actually driving the prop, and then the bolt is simply holding the hub to the flange, not spinning the prop. And so this is much more substantial, and it's a larger diameter. It's a much better system than using the bolt by itself. So those are threaded. Now we're going to switch over to non-threaded. There's no threads in these whatsoever. And these are aluminum. And 2, 4, 5, 6. And so what we're going to do is we're going to start off with our first one. We're going to come over. And now, very important, these are going to have to be inserted on this side. If you try putting it in on this side or sometimes down here, but over here is a good spot to start. And then we're just going to rotate this, so it's the same procedure. You're going to want to put the bolt in first, and then we're going to come in this way. Slides right in. We're going to bring this up into position and line up one of the holes. And once we get it there, we're going to start this by hand. I got a switch with you here. We're going to put our washer on, and then our nut. And now at this point, the prop can't fall back off the engine. I'm going to go ahead and turn it in the direction that it turns. And now we're going to do that again. We're going to keep going around until we've got all these started by hand. And then we're going to go in and torque these guys down. So again, coming in. And you don't want to tighten this down until all 6 of these are in. Otherwise, you may have trouble lining up the last 1 or 2. So we're just starting these by hand. And then down to the nylock. We'll go ahead and turn the prop again. So this is all AN hardware. You see it takes a little bit of a wiggle. And by the time you get the 6th one in, you'll definitely be probably wiggling these around just to kind of get everything. It is a nice snug fit. And I just keep working in this area here. On the REVOLT in particular, that is one of the most open areas. It's the easiest one to get to. This one is a ratchet wrench. That's going to really help us. And one of the benefits to not having all of these 15 bolts that hold this together in right now is that I'm going to be able to access all of these nuts very easily. So we're going to just kind of start here. I'm going to put my ratchet wrench on, and I'm going to snug these down by hand. And this is about the fastest way I've found to get in there. You can't get your impact wrench in there to, get them down. And now, just looking for a very soft pinch with one finger. Spin it 180 degrees. I'm going to keep working in this range, but now I'm going to spin it over. And my next bolt would be 180 off, which is this one. And we're going to go ahead and snug that down. And so I'm trying to just go snug by hand in a star pattern now. So the next one from here is going to be 180 degrees off. So we'll spin that around. And the main thing is our torque rating on all these bolts is 24 Newton meters. The main thing is don't go by hand anywhere close to 24 Newton meters. If you put your torque wrench on at the end and it clicks right away, you've gone too tight, which is bad. You may have compromised the bolt. You have to kind of start over with some new bolts. So don't go too tight. I'm just going snug on all 6, and then we'll start torquing. Some torque wrenches probably won't make it. Little bit of a tight squeeze, but there it is. And then you bring your wrench on. Sorry, I'm probably going to block your camera view here.
Nope,
and we're listening for the click. All right, so day 2, we lost batteries on the video camera, and we've actually finished up that propeller. Flies great, customer loves it, and we're doing another one. So here's where we left off. And I wanted to point out, this is the torque wrench that we use to get in there. A lot of times, even with the crow's foot, it can be difficult to reach. So this little guy here is perfect for this application. And if you want to come on this side here, I come through here, put this guy here, and wait for the click. And there it is. And we've gone ahead and torqued all of these. Come in here, just like that. So now we're torqued. And the next thing is we're held together still by our single bolt here, and we're going to go ahead and we're going to put all 5 of the centers in, and then the 10 on the outside ring. So here we go. Okay, so we're going to take our 5 bolts. Well, so I am finger tight with all of these, and now all I'm going to do is snug these up. I'm not trying to torque anything here. We're going to do that by hand, but this will get everything worked out. And we're just trying to take away workload of doing this by hand. If you go a little too tight, you have to back some of these off, but just getting them in. And one of the things I'm also doing is I'm working from the center out. And by working from the center out, I'm not having to work around other bolts. So the first bolts that we did onto the flange were a smaller diameter, now this diameter, and you get the torque set by hand. And that's all I'm doing is kind of just feeling this out. And then when I go to start rotating the blades, I will see if I need to loosen or tighten based on how the blade is rotating in the hub. And so just kind of feeling these out, getting them just snug. If you have the hub too loose and you attempt to pitch the blades, you'll be able to pitch them real easy, but they're going to move as soon as you start to tighten everything down. So now I've got these 5 down, and we'll go ahead and we're going to put in the next 10 right here. And then once again, we'll just start here. And I'm not doing a star pattern because we're torquing nothing down. We're just snugging things down. And just going in a circle here. The torque on these just to where they start to bite. And that should be about all you need. And you'll see in a moment when I'm adjusting the pitch, if it's too loose, how far it'll go per whack. And if it's too tight, a lot of times it just won't want to adjust. Now, next thing we're going to do is we're going to use our digital protractor, and we've got 2 things that we need to do. The first thing that everybody wants to do when we say zero out the protractor, which you need to do, it's very, very important that you are basing everything off of the engine, not, some of these trikes like our REVOLT sits at a 7-degree angle on the motor. Therefore, if you try matching the angle of this blade to the angle on a REVOLT where the engines are tilted different, you're going to be 7 degrees off. So the first thing you want to do is you want to zero out your protractor. Now the biggest mistake that gets made on a regular basis is that people will take their protractor, they will zero it out. So you can see we're at 1.3 degrees here. I'm going to zero that out. And now what they do is they rotate this 180 degrees over to the propeller blade. And we've just made that 1.3 degrees 2.6 degrees that we're starting with. So you can see right now I've got 27.35 degrees. Now let's do this correctly. We're going to zero this out on top of the hub. And now we're going to bring it over again. And now there's the real answer, is 28.4 degrees. So that's what we're looking at there. So very, very important that when you zero out the digital protractor, this may seem like common sense, but it's a very easy mistake to make, that you have to keep the orientation the same way from when you zero it to when you hang it on the propeller blade. Now we also have this bubble on top, very important. Take a look at how the angle changes when the blade is in a different orientation. So we're showing 28.4 degrees right now. I'm going to rotate this up a few inches, and now we're showing 27.95 degrees. So it is very, very important to make sure that all of your blades are in exactly the correct position. Now what we're running our REVOLTs at is 14.85 degrees, and that measurement is based on hanging this at the beginning of the leading edge. So instead of measuring out and putting our white marks, we're skipping a step. If you've seen the older video that we had that didn't have a good reference along the blade. So 14.85 is what we're looking for. We're going to take our trusty mallet. I can't stress this enough. Do not leave this on when you're rotating the blade. And we're going to tap the blade right here. And I can tell you right now, this blade's moving very nicely. So those few taps, just to give you an idea, we went from 28 degrees to 18 degrees. And now, maybe hard to see, but that's showing 18.4. And I put my finger here that helps me know how much the prop is turning. May or may not help you if you're not used to doing this often. But it's very helpful. Make sure my bubble is nice and centered. Come up just a little bit. And now I'm looking and I've got, oh, I went way past, didn't I? I'm down into the 10.5 degrees. So it's moving nice and easy. We got to get it close. And then we'll lighten up on those love taps. We're at 14, that's getting very close. 14.25. 15. Now we're just going to back it down very little. Still 15, didn't move. And when you're trying to dial it in, you know, just have to take your time a little bit. That's 14.90. And whether I get 14.85 can be a little tricky. 14.95. Or 14.75. So you can really kind of, once you get it that close, it's really tricky. There's your 14.85 right there. And so now, without touching this blade again, I'm going to carefully remove the protractor. I'm going to take my next blade. I'm going to bring my next blade back up into position.
So you want to get the bubble even?
Yep, get the bubble even. We need it in exactly the same spot, otherwise. And we're showing 32.35, so we are way out on this blade. Now, just because that one moved easy doesn't mean this one's going to move easy. Only if I torqued everything relatively equal will all 5 of the blades move equal. And that one seemed to move very nice, just about how I like it to move. 14. And I typically like to work them the other way. It's a little easier to take pitch out than it is to put pitch in. Just kind of a pro tip there, but here I am going the opposite way I like. All right, we're at 14.5. Bring this down. 14.7. Hair more. 14.8. And I think I'll stop there, trying to go from 14.8 to 14.85. And a lot of the digital protractors actually don't go out that last digit. This one does, so I just have a little bit more precision. And so we got 1 and 2. We'll go to number 3. And we're going to just continue and do the 3, the 4, and 5. And I'll show you what we do next. Okay, so now all of these blades are pitched at or right about 14.85. And you're welcome to use a torque wrench for this if you don't have a real good feel. But basically, in a star pattern now, I'm going to start to snug this down. So it's 175 inch-pounds for all of these bolts. And I'm going not near that right now. Therefore, I will finish this with the torque wrench. And we want to always start in the center of the hub and work our way out. And now we'll go ahead with these 10. And this can get a little tricky as far as which ones you've done, which ones you haven't. But I'll do my best here to get them going in a good star. And then before we get the torque wrench out, we're going to come back with the protractor. And if it was going to turn, now's the time that things are going to turn. And we want to just check and make sure. And most likely at this point, once everything here is snug and the blades are holding pitch, then when we do a final torque, the blades will probably hold that final pitch with no problem. Intermediate check. So 14.85. 14.85. 14.8. And we can be within 3/10 of a degree. That is an acceptable margin between all the blades. We're going to set our torque wrench to 175 inch-pounds, which I've done so. And again, a star pattern, so we're going to start here. There's our click, coming up to the top. Click, going over here. And so again, we're starting at the center, and then we're going to work our way out to the outer ring. And so after we run this for an hour, we'll do a retorque, and usually these bolts will turn all about 1/8 of a turn. And now we're going to come back to this one. Now this one's not 175 inch-pounds. If you look, there's actually a sticker here on the prop hub that has your torque settings. And so that's our 13mm bolt. It's metric, and so the torque is going to be 24 Newton meters on that. So just dialing that in. Nothing to hold on the backside. And yeah, that's taken quite a bit. Still going. There it is. And now our prop is torqued. Now we're going to do, before we start the engine, a final check on our pitch. And we got 14.85. So they did move a little bit after the final torque, and sometimes you have to just loosen it all up, go back, re-massage them again until you can tighten it up and get them all consistent within 0.3 of one another. And so at this point, we're ready to start this engine, and we'll probably go back to our flying aircraft and show you how it starts very, very smoothly, shuts down smoothly, and runs even smoother. Thanks for joining.